Welcome to The Explainer. Today, we're going to tackle a question that honestly comes up all the time. When you see a difference between two things, how do you know if it's a real, meaningful difference or if it's just, random chance? Well, we're going to break down the awesome statistical tool that helps you find the answer.
Just think about it for a second. Is that new diet really working? Is one class of students actually outperforming another? How do you go from just having a hunch to having a real conclusion?
And this right here is where the t-test comes in. It's a fantastic little method designed specifically to answer these kinds of questions by comparing the averages, or the means, of groups to see if they're genuinely different. And listen, if you want to understand all the different types of t-tests, you just have to remember this one simple idea. Keep asking yourself, what do things are actually being put head-to-head here? That's the secret. Okay, let's dive into our first scenario. This is the test you're going to use when you've got a single group of data, and you want to see how it stacks up against a specific known claim or some kind of standard. The one sample t-test is all about answering this one question. You've gone out, you've collected some data, and now you want to see if it holds up against a number that's already out there. Let's make this real. Imagine you're at the store, you buy a bag of rice, and the label says it weighs 1,000 grams. You get home, and maybe you're a little skeptical, so you weigh these 5 packets yourself. The big question is, are you really getting what you paid for? So look at what we're comparing. It's the average weight of the packets you measured, which comes out to 990 grams, versus that single fixed number on the label, 1,000 grams. A t-test basically tells you the odds that this 10-gram difference is just bad luck. If those odds are super, super low, you can be pretty confident the company is skimping on the rice. All right, on to our next tool. What happens when, instead of a fixed number, we want to compare two completely separate groups against each other? See, now we're asking a totally different question. We've got two distinct groups, and what we want to know is if their averages are significantly different from one another. Think about comparing test scores. You've got Class A and Class B. Now, just by looking at it, Class B's average score of 79.2 seems higher than Class A's average of 71.6. But is that difference big enough to matter? A t-test helps you figure out if it's statistically significant or if it's small enough that it could have just happened by chance. So the process here is really straightforward. We just calculate the average score for Class A, and then we do the same for Class B. The two-sample t-test then looks at the gap between those two averages to tell us if there's a real, meaningful difference in performance. Now for our last scenario. And I gotta say, this one's my favorite because it's all about measuring change within the very same group. The whole question here is about tracking progress. We're looking at the exact same people, but we're measuring them at two different points in time, usually before and after some kind of event or an intervention. A classic example is a new diet plan. You want to know if it actually works, right? So you weigh 5 people, they follow the diet for a month, and then you weigh them again. So notice it's not one group of people versus another. It's the weight of the very same person at two different moments. Person 1 lost 4 kilos, person 2 lost 3, and so on. A paired t-test looks at the average of these individual changes to tell you if the diet had a real statistically significant effect overall. Okay, so we've looked at 3 different scenarios, 3 totally different questions. Now let's pull it all together into a simple framework that you can use anytime you want. This table just puts it all side by side so clearly. Do you see the pattern? It always comes down to what you're comparing. Are you testing against a benchmark, comparing two totally separate groups, or are you tracking change within the same group? The answer to that question points you directly to the right test every single time. And this slide right here, this is your mental checklist. Think of it as your rule of thumb. Just by figuring out if you have one group versus a number, two different groups, or the same group measured twice, you'll instantly know which tool to grab from your toolkit. It always comes back to that core idea we started with. What exactly is being compared? Because at the end of the day, the t-test is so much more than just a statistical formula. It's a framework for thinking critically about the world around you. It gives you a real way to challenge claims and to verify differences for yourself. So now that you have the rulebook, what question are you going to go out and answer?